Today I will introduce the UHV-108kVA/108kV variable frequency series resonance, produced by our company. The variable frequency series resonance we use. Its maximum voltage is 108 kV. We use it to do a no-load test to demonstrate it to you. First, the instrument must be reliably grounded. Then connect two output lines. These two output lines are connected to the transformer. Then the control source is input to these two lines of the transformer. There is no positive or negative polarity on these two sides. Then connect to the high voltage tail. These two lines are connected together. Remember to ground the high voltage tail. It can be connected here, it can also be connected here. But it must be grounded. Then go to one of its output directions. Because its connection method is based on the terminal. Now with this connection method, its maximum output voltage is 6000 volt, so here it outputs a voltage of 6000 volt. The output is generally in this place. Then this is an output terminal, output to the reactor. The transformer directly inputs to the reactor. Note that this line can be placed on the ground. The lower part of the reactor must not be placed on metal. Otherwise, the voltage will not rise. Then it will come up from the reactor. These two are connected in series here. After the series connection, this side will also be connected in series. Note that this line must be connected in short wires, and never use a boost short wire. It must not be pulled down like this. After the series connection, the two parts above are also connected in series. After the series connection, the voltage at this place has reached the highest. From this place to the booster, it is important to note that this line must be kept suspended, and keep a safe distance from the highest voltage of the electronic control system to the transformer. Note that this line must be kept suspended. There is enough height and safety distance to the ground. It is a high voltage line, and it is absolutely not allowed to touch the ground. This line must also ensure a sufficient minimum height, and there must be no metal around. Booster wiring. First, we must make reliable grounding. Ground here, then connect the data line. These are also signal lines. Make sure to connect well. Otherwise, no signal can be collected. Then collect the signal from here to the instrument host, that is, the frequency conversion source. This is a signal line, connected from the voltage divider. Connect to the frequency conversion power supply, which is the signal line of the host. This place must be connected well, plug it tight. The instrument is connected to a 380V power supply. Turn on the power. The instrument will slowly enter the power on state. First, we click on parameter settings. There is no need to set it here. Because our voltage divider ratio is rated, it has been set. What we need to set is its test voltage and test time. For the test voltage, just click directly, and then enter 108. For the test time, we set it to 1 minute. After setting it, you can directly click return. There is an automatic experiment here. For the automatic experiment, you only need to click start, but if we want to use manual experiment now, we need to click start, and then increase the voltage step by step. Now we use manual test. Click to start the test. After clicking start, the high voltage indicator light will light up. Then click to adjust, to find its resonant frequency. You can see this waveform, which is the process of finding the frequency. After the frequency is found, we enter the state of manual voltage boost. You can see that the voltage near me is 2 kV, which means that it will rise 2 kV every time I click. Now we raise it to the rated voltage. We have reached 108 kV. Click to start timing, and the instrument will start timing now, for 1 minute. OK, 1 minute has passed, then click voltage reduction and shut down. The instrument enters the voltage reduction and shutdown state, and the voltage has dropped. We can click to save, or choose to print. Then there will be the test results. Now we have finished the manual experiment. Return, let's try its automatic experiment. Enter our automatic experiment, and click to start the experiment directly. The instrument automatically boosts the voltage, and automatically enters the state of finding the frequency. We see that the instrument has found a frequency, and then it automatically enters the state of voltage increase. After reaching 108 kV, the instrument automatically enters the timing state. Because we set it to 108 kV, 1 minute. After 1 minute, the instrument automatically reduces the voltage and stops. The test is completed. We can choose to confirm. And then click Save or Print. Now the test is completed. Return. Turn off the power. And finally discharge.